In problem 2, we explore monopoly power further. First, we look at price discrimination, and then we look at price determination in an oligopoly using game theory. So here we have the demand curve because there's a negative slope, and the supply curve which has a positive slope. Here's demand, here's supply, this is price, and this is quantity. Where demand and supply meet is called the competitive equilibrium. And it looks like the value at the competitive equilibrium is about just a little bit over 1,000, and the equilibrium price is between probably 300 and 350. Suppose the demand curve above represents the maximum price each individual consumer is willing to pay for a smartphone, such that 1. The first smartphone is sold to a consumer that is willing to pay at most $748.60. Now, how did I get that number? Well, I copied this part of the demand curve into Excel, and then I'm going to substitute 1 in for Q. So here's the demand curve, and I replaced Q with A2. So I got the intercept minus the slope times 1. And you get $748.60. The second smartphone is sold to the consumer that was willing to pay at most $748.20. Where does the $740.20 come from? Again, I'm going to replace Q here with 2. So A3 is 2. Plug that in the demand curve, and we get $740.20. Now I need to calculate the maximum the third consumer is willing to pay for the third smartphone sold. So I'm just going to replace Q up here with 3 in Excel. So here's the demand curve, and I'm replacing Q with whatever's in cell A4, which happens to be 3. So the third consumer is willing to spend up to $747.80. What about the 1,000th smartphone? The 1,000th customer is willing to pay $349. Where does the $349 come from? Well, this is the demand curve, and I'm replacing A4 with what is in cell A4, 1,000. So the 1,000th smartphone customer is only willing to pay up to $349 for a smartphone. If the smartphone market has been monopolized by one firm, and that firm engages in first-degree price discrimination, the monopolist will sell how many smartphones? First-degree price discrimination is a scenario that really doesn't happen in the real world, because the firm who has monopolized the industry charges each consumer the maximum they're willing to pay for the product. Producer surplus in a competitive market would be this triangle down here. Consumer surplus would be this triangle up here. But when we have a first-degree price discrimination monopolist, because the firm is able to charge each consumer the maximum they're willing to pay for the product, this whole triangle becomes producer surplus. So first-degree price discrimination allows the firm to take everyone's surplus, all consumer surplus. So the equilibrium in this situation is identical to the equilibrium in the competitive market. In order to compute the equilibrium quantity for a first-degree price discrimination monopolist, we have to copy the demand and supply curve into Excel and then solve for Q. I've copied the demand and supply curve from the problem into Excel, and then I set demand equal to supply. And then I subtract 35 to the left and add 0.4Q to the right. Then I factor the Q out on the right. And then I divide both sides by this coefficient of Q. So the equilibrium quantity is 1020. If I plug this into the supply curve, or I plug it into the demand curve, I'll get the price of the last smartphone sold. I plug this quantity into the demand curve and I get $341. If I plug it in the supply curve, I get the same thing, $341. So the 1020th customer will pay a price for a smartphone equal to $341. Because the monopolist is charging each consumer the maximum price each is willing to pay, consumer surplus is zero. Producer surplus is this triangle from here to the intersection of demand and supply up to the price axis, the intercept on the price axis, down to the intercept on the supply axis. So all I do is I take the demand intercept, subtract off the supply intercept. I multiply that difference by the equilibrium quantity, and I divide that by 2. The height of that triangle is the difference in the demand intercept and the supply intercept. So the height of the triangle is 714. The width of the triangle is the quantity that we computed. The producer surplus is the height of the triangle times the width of the triangle times 0.5. So producer surplus is 364,140. So in summary, a first-degree price discrimination monopolist sells its output to consumers for prices that are equal to each consumer's maximum willingness to pay. That allows the first-degree price discrimination monopolist to take all of the consumer surplus. And so producer surplus equals the total surplus if this were a competitive market. Suppose the monopolist realized that it is impossible to charge customers different prices. So instead, it charges 3 types of customers different prices. It charges parents $647, youth $545, and retired folks $443. In number 1, we want to know how many units the firm sells at the price of $647. And then we want to know how much the firm sells at $545. And then we want to know how much the firm sells at $443. I've copied these 3 numbers into Excel and the demand curve, determining the quantity of smartphones sold. So I have the demand curve here, price 1, price 2, price 3. Then I also have copied in the demand and supply curve from the problem, and this dashed line corresponds to a price of about 647 and a quantity of just over 200. Instead of just guessing from the diagram, we're going to actually calculate the quantity. So I'm going to set the price, 647, equal to the demand curve, 749 minus 0.4 Q. Then I want to subtract 647 from both sides and then add 0.4 Q to both sides. Next, I want to divide both sides by 0.4 Q. In Excel, to do the calculation, I have to get rid of the Q here. And I get a quantity of 255. So at the price of $647, which is about right here, the quantity is $255. To do the same for the second price of $545, I'm going to copy this equation here and just replace the 647 with 545. And I get a quantity of 510. So the price of 545, which is about right here, the quantity is 510. To compute the quantity at a price of 443, I'm going to copy this stuff and paste right here, and then change the 545 to 443, and I get a quantity of 765. So the price of 443, which is right about here, we get a quantity of about 765. Next, I want to calculate the consumer surplus, producer surplus, and the deadweight loss. The consumer surplus is three areas. The area in this triangle up here, the area in this triangle, and the area in this triangle. First, the area in this triangle is the intercept of demand curve minus the first price of 647. That's the height. The width of this triangle is that first quantity. So I have to calculate the height of that first triangle, which is the intercept minus that first price of 647. The width of that triangle is the 255. So consumer surplus 1 is equal to the height times the width divided by 2. The height of this triangle here is the difference in those first two prices. The width is the difference in the first two quantities. So the height is the difference in these two prices. The width is the difference in these two quantities. The consumer surplus is the height times the width divided by 2. For the third triangle, for the third consumer surplus, we have the height of the triangle being the difference in the last two prices, and the width of the triangle being the difference in the last two quantities. So the height is the difference in the two prices, while the width is the difference in the two quantities. And the consumer surplus is the height times the width divided by 2. Overall consumer surplus is the sum of the three. So consumer surplus is 39,015. Deadweight loss is this triangle here. The height of this triangle is the last price, 443, minus whatever this price is. How do we get this value? We plug in that final quantity, 765, into the supply curve. The supply curve was P equal to 35 plus 0.3 Q. So I drop the P, and then if I click on this quantity here, I get a price curve along the supply curve equal to 264.5. So I just found this value, which is 264.5. So the height of the deadweight loss triangle is the difference between the last price, 443, minus the value on the supply curve that corresponds to this level of quantity, 765, which is 264.5. That difference is the height of the deadweight loss triangle. If you recall from the previous subpart of this problem, the intersection of the demand and supply was 1,020. That's important because the height of this triangle, or the width of this triangle, is the difference between this value 1020 and whatever this value is right here, which is 765. So we're going to take the height of the deadweight loss triangle and multiply it by the difference between 1020, which is this value here, and the 765. Then we're going to divide that by 2. So deadweight loss is 22,758.75. There's a couple ways to get the producer's surplus. One way is to calculate the area of this trapezoid, and this trapezoid. The other way to do it is to calculate the area of this huge triangle here, which is the total surplus in a competitive equilibrium. And then subtract off the consumer surplus, which is the area of that triangle, the area of that triangle, and the area of that triangle, and also subtract off the deadweight loss. The total surplus for the competitive equilibrium is the intercept of the demand curve, 749, minus the intercept of the supply curve, 35, times the competitive equilibrium, 1020. Divide that by 2. So the total surplus in a competitive equilibrium would be 364,140. So the producer's surplus is this minus the consumer surplus minus the deadweight loss. So you can easily tell that the producer surplus is much larger than the consumer surplus.